Hello, welcome back to Unit 9, Section 4. And what we're going to be doing here is we're going to be talking about the sum and difference identities in trig functions. Okay, so we're going to use the sum and difference identities for the sine, cosine, and tangent functions. So the point of this, just so you know, is to, we can evaluate trig functions with non-unit circle angle measures. Okay, so we will be using the unit circle angle measures, not measures. We'll use the unit circle angle measures, but we'll have like some weird angle measures and you'll be like, wait a minute, how do we get that? So let's do this, okay? The sum and difference identities for the cosine function. So what I want to do, let's have this. We're going to use alpha and beta, okay, are two different angle measures. Okay. Okay, and so let's say that I have this. Let's say I have this angle measure here. We call it cosine of alpha plus beta. Okay, and what I can do is I can do cosine of alpha times cosine of beta minus sine of alpha times sine of beta. Okay. All right, so that's the sum of cosine values. Now, if I have cosine of alpha minus beta, okay, that's going to give me cosine of alpha times cosine of beta plus sine alpha times sine of beta, okay? And so the way I remember this for cosine is, if we're dealing with cosine, I think of cosine, cosine, sine, sine. It's like this little thing that I sing to myself. So if we're dealing with cosine, sum or difference, cosine, cosine, sine, sine, okay? And then notice here how if I'm adding my angles, within expanding this out, I subtract my angles, okay? And so the signs are going to be opposite, all right? So let's use this, all right? Let's do a practice problem. So what we want to do, so in our example, is we want to find the exact value of cosine of 75 degrees, okay? Now, what I know about cosine of 75 degrees is you look at this and you're like, well, I have absolutely no idea, right? But what we can do is we can split 75 degrees into the sum of two numbers, usable numbers from the unit circle. So I can rewrite this as, say, cosine of 45 degrees plus 30 degrees, okay? And so what I want to do is, realize that, this is my alpha value, and 45 is alpha, and then 30 is beta, okay? And what we can do is then just plug that into our formula, and we can evaluate, so cosine, cosine, sine, sine, okay? So cosine of 45 degrees times cosine of 30 degrees minus sine of 45 degrees times sine of 30 degrees. Okay, so now we have to use these values and evaluate. So cosine of 45 degrees is simply just going to give us the square root of 2 over 2. Cosine of 30 degrees Okay, so cosine of 30 degrees is going to be square root of 3 over 2 minus sine of 45 degrees, which is root 2 over 2. And then sine of 30 degrees is simply just going to give us 1/2. Okay, so kind of a cool, unique thing that we've got going on here. Let's multiply these out. Now, square root of 2 times the square root of 3 is the square root of 6 over 4. 2 times 2 is 4. Minus the square root of 2 times 1 is the square root of 2 over 4 as well. And so with a common denominator, I would just write this simply as the square root of 6 minus the square root of 2 all over a common denominator of 4. And so what we see here is that's the exact value of cosine of 75 degrees. Okay? And that's how we use that. So, you know, all we're doing is splitting this up into, you know, something usable, you know, values that we can calculate, and then putting that in. Okay, let's do another one that's a little bit trickier. Okay, same thing. We want to find the exact value of cosine of 735 degrees. Okay, this one's a little bit trickier because it's not apparent as to what we need to do. Okay, so if we evaluate 735, okay, if I take 735 and I subtract off 360, that's going to give me 375, okay, which is still more than 360, so let's subtract off another 360, and that's going to give me a value of 15 degrees. So us evaluating cosine of 735 is the same thing as us evaluating cosine of 15 degrees. Okay, this is still going to be in quadrant 1, all right? All right, so now with that, because all I'm doing is subtracting off 360 from each of those, okay? So now I want to evaluate this. So now using our, our angles of 30, 45, 60, okay, I could do this. I could do cosine of 45 degrees minus 30 degrees. So we're kind of doing the opposite, all right? So at this point, cosine, cosine, sine, sine, opposite sine. So I'm going to do cosine of 45 degrees times cosine of 30 degrees plus cosine of 45 degrees times sine of 30 degrees. Okay, so similar to what we were doing, cosine of 45 is root 2 over 2. Cosine of 30 is the square root of 3 over 2 plus square root of 2 over 2 times 1/2. So it's the same thing, same numbers. So this is the square root of 6 over 4 plus the square root of 2 over 4. And that's going to end up giving us the square root of 6 plus the square root of 2 all over 4. Okay, and that would be equivalent to us doing cosine of 735 degrees. All right, so pretty cool, okay? And you can always find approximations, all right? And the one way to check, you can use a calculator. You know, make sure you're in degree mode for this. Do cosine of 75, see what you get. Square root of 6 minus square root of 2 over 4, see what you get. You should get the same thing. All right, so let's go through and let's talk about the sum and difference identities for the sine function. Again, we have the same idea where alpha and beta are both angle measures. Okay, so if I had sine of alpha plus beta, that would give me sine of alpha times cosine of beta plus, so the signs stay the same, cosine of alpha times sine of beta. Okay. Similarly, same thing if we do the difference. So if I do sine of alpha minus beta, it's going to give me sine of alpha times cosine of beta minus cosine of alpha times sine of beta. Okay. And so the way I remember this, if we're doing sine, sine, cosine, cosine, sine. Where the one above it was cosine, cosine, sine, sine. Sine, cosine, cosine, sine. Cosine, cosine, sine, sine. You know, whatever works for you. That's how I remembered it. Okay, so let's use this, okay? So let's do the same ones. Okay, let's do sine of, say, 75 degrees, okay? So if I'm doing sine of 75 degrees, I can split this up and do sine of 30 degrees plus 45 degrees, okay? So sine of 30 times cosine of 45, all right, plus cosine of 30 times sine of 45. Okay, so let's evaluate this. This is going to give us sine of 30 is 1/2 plus, times cosine of 45, which is the square root of 2 over 2, plus cosine of 30, which is, what is that? Root 3 over 2 times the square root of 2 over 2. Okay, so this is going to give us the square root of 2 over 4 plus the square root of 6 over 4. Okay, so we're going to get the square root of 2 plus the square root of 6 over 4. And that would equal sine of 75 degrees. Okay? Similarly, if we do, and I'm just going to jump right in, and let's find the exact value of, say, sine of 15 degrees. We won't do the 375 or whatever it was. I'm going to write this out as sine of 45 minus sine of 30. 45 minus 30. I don't need to put the sine in there. Okay. Sine, cosine, cosine, sine. So sine of 45 times cosine of 30 minus sine, cosine, cosine, sine. Cosine of 45 times sine of 30. So this is going to give me square root of 2 over 2 times square root of 3 over 2 minus cosine of 45 degrees, which is going to give me root 2 over 2 times 1/2. Okay, and so I'm going to get the square root of 6 over 4 minus square root of 2 over 4. Combine these together, and that's going to give me square root of 6 minus the square root of 2 all over 4. And you're probably noticing something unique about this, is that we're like, hey, this is just like the opposite, right? But think about it. Okay, think of a triangle, all right? So I know we're kind of using the same one here. You don't need to write this down, but here's 90-degree angle. Let's say that this is 75 degrees and this is 15 degrees. Okay. If I'm taking 15 degrees and taking that, what I'm doing is I'm taking, here's the opposite side, here's the adjacent side, here's hypotenuse. Okay. So if I think about you know, doing, say, sine of 15 degrees, okay, that's going to give me my opposite side over hypotenuse. If I do cosine of 15 degrees, that's going to give me adjacent over hypotenuse. All right. If I take the perspective of 75, opposite, hypotenuse, adjacent, think about it. If I do sine of 15 degrees, or 75 degrees, okay, that's going to give me opposite over hypotenuse. Okay. Now, taking this perspective here, sine of 75 is the same thing as adjacent over hypotenuse, okay, taking the view of my 15-degree angle, okay? So these two things are the same, and that's why you're getting the same thing over here. So sine of 15 degrees is square root of 6 minus 2 over 4, but up here when we did cosine of 75, got square root of 6 minus square root of 2 all over 4. And so these things are the same, and these things are the same. Okay, but you just have to go back and think of the triangle and how that works, because we're essentially doing it to the same triangle. Okay, the next one, some difference identities for the tangent function. So same thing, alpha and beta are angle measures. Okay, and then what I want to do is I've got my sum formula. So I've got tangent of alpha plus beta, and that's going to equal tangent of alpha times, or I'm sorry, tangent of alpha plus tangent of beta over 1 minus tangent alpha times tangent beta, okay? On the other one that we would have, okay, so if we go the other way, tangent of alpha minus beta is going to give us tangent alpha minus beta, tangent of alpha minus tangent of beta over 1 plus tangent alpha times tangent of beta. Okay, so the way I remember this one, and I just remember the first one, okay, tan plus tan over 1 minus tan tan is how I remember that saying. Okay, so if you use those over and over again, that will help. Here, tan minus tan over 1 plus tan tan is when you have negative. So your sign up here is the same, your bottom is opposite, okay? So let's use that, okay? Let's find the exact value. So exact value of tangent of 285 degrees, all right? So real quick, let me just draw out my unit circle here just so I know where 285 degrees is. So one, down to here, this is 270. So this over here, and add 15 degrees, and that's going to give us a value of 285 degrees, okay? So what we want to think about is how do we use 285 degrees? And so if we use, okay, so on this one what I'm seeing is that we'll take the next closest one, okay, which is 315 degrees, okay, and what I want to do is I'm going to subtract off 30 degrees from that, which those two would yield together to give me 285. So I'm going to do, so to get tangent of 285, and we can do this a couple different ways. All right, so let's rewrite this as, I'm going to do tangent of 285. Okay, I'm going to rewrite that as tangent of 315 degrees minus tangent of 30 degrees. No, not tangent, just minus 30 degrees. I don't know why I keep doing that. Okay, so all you need to do is split this up into the sum or difference of two angles that we know. Okay, now before I do anything, let's evaluate tangent of 315. Okay, remember that's going to be sine of 315 over cosine of 315. So negative 1. Okay, so this is negative root 2 over 2 over square root of 2 over 2. Something divided by itself is just going to give us negative 1. Okay, so we have that value here. Let's do tangent of 30 as well, just so we have those. So we're not doing that every time. So we're going to get sine of 30 over cosine of 30. So sine of 30 is 1/2 divided by square root of 3 over 2. So this is going to be 1/2 times 2 over the square root of 3. 2's divide out. We've got 1 over root 3. Rationalize our denominator. And so that's going to give us square root of 3 over 3. Okay. Yeah, we want to get exact answers out of that. Okay, so that's just the kind of stuff we got to be able to do by hand. All right, so tangent of 30 equals this. Okay? All right, so now that we have those values, all right, let's do tangent of 315 minus tangent of 30 over 1 plus tangent of 315 times tangent of 30. Okay? So tangent of 315, remember that was just going to give us negative 1 minus tangent of 30, which is going to give us, what was that, root 3 over 3, all over 1 plus tangent of 315, which is negative 1 times the square root of 3 over 3. Okay? So now, all right, so let's simplify this. This is where it gets hard, this arithmetic. Okay. I'm going to do negative 1 over 1 minus root 3 over 3 divided by 1 minus square root of 3 over 3. And we want to get this into one single fun fraction. Okay? What I'm going to do, I'm going to get a common denominator. I'm going to put this one over 1 as well. So multiply top and bottom by 3 over 3. This one I'm going to multiply by 3 over 3. Okay? So then this is going to give us negative 3 minus the square root of 3 over 3 divided by 3 minus the square root of 3 divided by 3. Okay? And when I have this, okay, two fractions divided, I'm going to do negative 3 minus root 3 over 3 times 3 over 3 minus the square root of 3. 3's divide out. Our exact answer is going to be negative 3 minus the square root of 3 over 3 minus the square root of 3. And you may think that you could like divide things out and you should get 1 out of this, but you can't. Okay, and the reason why is because if I factor out a negative 1 here, like this is our answer. We just want to stop here. Okay, if I factor out a negative 1 here, I'm left with 3 plus the square root of 3. If I factor out a negative 1 from the bottom, I get negative 3 plus the square root of 3. And they're opposites. Okay, so it's kind of funky, but you want to just stop here. Good. Good. All right, let's take a look. All right, let's just stop here. Okay, and we'll go from there. We'll work on the identities in class. All right? Thanks for watching. See you later. Bye!